Implement a robust security monitoring and incident response system using Azure and Splunk by Mason and Joe. In this project, we are creating resources that can be used by a real company and have a security monitoring setup, but for a fictional company called Mason's Awesome Company. We evaluated the needs of the business to set up the IT needs as well as a security monitoring system. A full training of monitoring system is also provided. Now I'm going to explain some of the terminologies. What is Azure? Azure is Microsoft Cloud Computing Platform that offers a wide range of services to help you build, manage, and deploy applications on a global network. It easily adjusts resources based on your needs, supports various operating systems, languages, and tools, provides robust security and compliance options in many levels, and is available in many regions worldwide. Now, why we choose Azure for Mac? For its cost effectiveness. Pay only for what you use, and when no longer needed, you can terminate. Performance-wise, it has high-speed connectivity and reliable uptime. And when it comes to integration, it seamlessly works with existing Microsoft products and other popular platforms, such as Splunk. And what is Splunk? Splunk is a powerful platform that helps you collect, analyze, and visualize machine-generated data from various sources. In simple words, it can help turning complicated data generated by machines into easy, human-readable version. Now, if you want to know more about Splunk, it has many features. The main ones being the data collection ability. It can gather data from logs, application servers, databases, and so on. And its real-time analysis provides insight and alerts as events happen, as we will present to you later in this presentation. Now, troubleshooting, security, and compliance. That's why we chose Splunk for Mac. It helps quickly identify and resolve issues, detect and prevent security threats, ensure you meet regulatory requirements, and it's also a leading platform used across many industries. Now, before we continue, I quickly mention that all aspects of this project were conducted legally, utilizing resources that Joel and I either own or had authorized access to. Now, after conducting an interview with the director of Mason's Awesome Company, we determined that the business needs 4 servers for its operation. You can see in this diagram here that we drew up how it was set up. We have one web server that hosts the company's website. It's configured to handle incoming HTTP and HTTPS requests, serve web pages, and manage user sessions. It has the web server software Apache and manages traffic and serves contents. Next, we have an application server serves as company's application logic. It's responsible for processing user requests, business logics, and connecting to the database. It basically handles communication between the web server and the database. Now, the database contains the management system MySQL. It manages data storage, queries, and transactions. The management server is used for managing and maintaining the overall company's infrastructure. It provides administrative tools and monitoring capabilities. It contains management tools such as Ansible and hosts our Splunk Enterprise. Now, the Azure Virtual Network enables secure communication between VMs and other resources. It also provides network isolation and segmentation. As you can see in the diagram again, each of our virtual machines is separated by their own network security groups. Now, the good thing about Azure is that it can be easily scaled up or down based on the project requirements. For example, for this project, we initially had trouble using Splunk, but after consulting experts in this field, Cameron in this case, we scaled up our machines to a higher CPU and memory capacity and solved the problem in minutes. Now, for this project, we used waterfall methodology as opposed to agile. Each phase of project was completed one after another. We started by comprehensive planning and documenting, although some changes were made along the way. As you can see here in our documentation, that we planned everything ahead of the time, and we knew exactly what to expect and what our next step would be. We then proceeded with creating our resource groups and virtual networks. Network security groups was created and necessary rules was applied for connectivity and security purposes. NAT gateway was created next. This would work like a router and connects all our network together. A routing table was next to ensure traffic flows as intended for each of our servers. We then proceeded to creating our virtual machines. After creating all VMs, we created a bastion, which was not included in our original planning, but found out later that is necessary in order to create a SSH or RDP connection to our virtual servers, which, as you will see in this video, we managed to establish a connection and install our monitoring system and forwarders. This finalized sped up video shows how we connected to our management server and installed the Splunk based on the documentation and resources on the website. And after that, our monitoring system can be loaded from any browser with internet connectivity. The analysts, of course, need the correct credentials to log in, which we apply during the installation process. But the data flows in there in real time all the time. Of course, it will need to become true by analyst. You can see the live data here. Next, I will hand over to Joel, who will demonstrate how he used some tools trying to attack our machines and how our monitoring system reacts.
Hey guys, I'm going to start by introducing a little about what Hydra is and why we've chosen to use it in this section of our project. Our goal here is to execute a brute force attack against our system, which has been integrated with Splunk, to allow us to track the logs of the attack in real time. With this operational visibility, we can view a live tracking of our system performance, which makes it easier to spot issues when they arise. Hydra is an open source network login cracker widely used in cybersecurity to test the strength of passwords on different systems. It's highly versatile, supporting a variety of protocols like HTTP, FTP, and SSH, making it suitable for assessing password security across numerous platforms. Hydra performs brute force and dictionary attacks by trying multiple username and password combinations to identify weak or default credentials. Known for its efficiency, Hydra is especially valued for quickly testing large volumes of login attempts. Here we have a demonstration on using Hydra for brute force password testing in an ethical hacking context. I have set up and installed Hydra in the Guacamole Ubuntu system ready for our project. As you can see here, I've preloaded the input to run Hydra using the username that Mason has created with the Azure network, whilst also adding his password into our password list just far down enough so I can yap on about how it all works. This input references said password list along with the network's IP address to SSH into. As I execute the command, Hydra will start testing the username and passwords against the SSH service on our target machine. We'll also see on the left here a Splunk interface to start collecting logs on the brute force attack and display them in real time. Depending on the protocol, we can modify Hydra's commands to fit the different services like FTP or HTTP. For example, a web login form could be tested with the HTTP post form option, specifying the login page, fields, and expected error messages. As Hydra runs, it will report any successful login attempts directly in the terminal, allowing us to review our findings immediately. This is particularly useful for identifying weak credentials in controlled authorized environments. In a few seconds, you'll see here that our brute force attack has discovered Mason's password using our password list. So that should pop up any second now. And I think we can all agree that Mason could have used a slightly more complex password. If this were a real life scenario, Mason's account would be compromised, which could lead to potential leaks of private information, privilege escalation attempts, and much more. Always remember, tools like Hydra should be only used with explicit permission, as unauthorized use can be illegal.
Thank you, Joel. I should choose my passwords more carefully from now on. On that note, we now open the floor for any questions that you might have.